The ocean can sink a ship, but it cannot erase a legend. Today, join RaWMachines as we explore the resurrection of the Götheborg, a vessel that lay at the bottom of the sea for over 200 years. From harvesting timber in the forests and processing it at the sawmills to the final assembly in the shipyard, every step represents a journey demanding immense patience, master craftsmanship, and flawless precision. Let's get started. We would like to express our sincere gratitude to the Swedish East India Company and Sophie A. for providing and creating this invaluable footage. In 1731, the Swedish East India Company was born, opening a trade route that spanned decades between Europe and China. Dozens of ships crossed the oceans, carrying silver and returning with tea, silk, spices, and porcelain. One among them was the Götheborg, a symbol of aspiration and endurance. However, on September 12, 1745, while less than a kilometer away from the port of Götheborg, the ship met its tragic end and sank. More than 2 centuries later, a bold idea sparked. If the ship no longer existed, could humanity recreate it from memories and remnants? Thus, in 1993, a new Swedish East India Company was established to turn this vision into reality, not merely for display, but to restore a piece of memory that once belonged to the ocean. With this project, the material requirements were not only immense, they were demanding to the point of being nearly absolute. Over 4,000 cubic meters of timber were utilized, the majority being oak, a wood renowned for its exceptional durability and high load-bearing capacity, while the remainder consisted of pine, which is lighter and more flexible for structures requiring significant curvature. Once the materials are ready, the ship enters its most critical phase, the formation of the framework, which determines its entire silhouette and its ability to withstand the forces of the open ocean. Rib sections spanning up to 14 meters are crafted from laminated pine. Adhesive is meticulously applied to each layer of wood, which are then pressed together using dozens of clamps, roughly 70 per section, spaced a mere 20 centimeters apart. Under that immense pressure, the wood gradually surrenders its original form, curving according to the predetermined design, as if being persuaded to become a living part of the vessel. As the ribs are finalized, they are hoisted and set upon the keel. A total of 66 frames, each weighing approximately 2 tons, are placed into position one by one, giving birth to the ship's initial silhouette. Temporary crossbeams hold them in place, while the joints are coated in pine tar to enhance both the seal and the structural longevity. Once all the ribs and crossbeams are properly positioned, the next step is the installation of the stem, a component consisting of 3 distinct sections. The connection between the keel and the stem is achieved using a half-lap joinery technique. Simultaneously, the stem must be reinforced with temporary struts and braces to ensure total stability as the structure grows. Parallel to the shaping of the wooden hull, another world is in constant silent motion. More than 20 tons of nails and bolts, approximately 56,000 individual pieces, are not mass-produced in a factory. Instead, they are handcrafted right at the shipyard. Each iron rod is heated to a glowing red, then under decisive hammer blows, is gradually forged into the fasteners that will bind the entire wooden structure together. Most notably, the knees, each weighing up to 80 kilograms, act as the joints of the ship. These are not simply manufactured according to a static blueprint. They must be continuously dry-fitted directly onto the hull, then carried back to the forge for fine-tuning. This process repeats multiple times until every detail achieves a near absolute fit. It is a marriage of technical skill and sensory intuition, where the artisan doesn't just look, but feels the precision of the metal against the wood. Beyond the structural framework, the rigging system also requires a large number of metal components such as hooks, washers, and brackets, with a total weight exceeding 50 tons of steel. These parts may be small, but they are responsible for transferring the force of the wind throughout the entire hull. Here, the contrast becomes clear. If wood provides form and buoyancy, then iron is what holds everything together. And it is this combination that creates a structure both flexible and durable, strong enough not only to endure, but to conquer the ocean. These massive logs must first be sawn before they can be used as beams and planks, then carefully dried to ensure stability before being put into use. The hull is planked from the inside outward. In high-stress areas, especially along the sides where the hull curves sharply, longitudinal beams are added for reinforcement, creating a structure that is both strong and flexible. The thickest planks can reach up to 16 centimeters, so heavy and rigid that installation requires clamps and specialized lifting equipment. Before nailing, each hole must be drilled precisely to prevent the wood from splitting. And as each plank is secured, the vessel gradually closes in, transforming from an empty frame into a more complete structure. As the hull nears completion, the rope system begins to take shape. It is made from hemp fibers, with the requirement that the strands be as long as possible. Before use, the fibers are treated with tar to prevent decay, and controlling the amount of tar is a key factor in ensuring quality. Around 100,000 kilometers of hemp fibers are cleaned and fed through the system before being tarred and twisted into rope. The strands are then hand-braided into bundles to achieve the desired strength and durability. From the individual hemp fibers, the rope-making process begins. Each small layer of fiber is braided into a complete, strong, and flexible rope, capable of withstanding the force of the wind and the sails. This work is carried out in collaboration with a traditional rope-making facility under the supervision of expert Ola Magnus, who ensures every rope meets quality standards before the ship can set sail. Once finalized, the ropes are not put into immediate use. Instead, they undergo several processing stages, installing stoppers and lashings, applying protective coatings, and pre-stretching to stabilize the structure. The heavy shrouds, which keep the masts standing upright from both sides, are meticulously installed, including critical knots at the bow that demand exceptional craftsmanship. The entire rigging system weighs approximately 30 tons, with rope diameters ranging from 10 to 19 millimeters, connected through nearly 1,000 pulleys. This creates a network that is both flexible and incredibly precise. From small single pulleys to large blocks for hauling sails, a wide range is required. These pulleys are made from elm wood and come in many different shapes and sizes. Each one is carved from a single solid piece of wood to ensure strength, with no weak points from joints. Starting from a rough block, the craftsman uses a saw to shape it, then refines it by hand, especially the cavity where the pin is placed. Afterward, the pulley is treated with linseed oil to resist moisture and reduce friction during operation. Though simple in form, when combined with rope, they create an efficient force transmission system, allowing large sails to be controlled by human strength, a clear example of the elegance of traditional design. The ship will be adorned with various wood carvings. Notably, the name Götheborg will not be written in letters, but represented through symbols. The stern features the coat of arms of the city of Götheborg, while the bow is decorated with a figurehead and the elm flower symbol representing the company. To ensure the planks can hug the complex curves of the hull, the wood must be softened with steam at approximately 100 degrees Celsius for several hours. Afterward, the shipwrights have only about 15 to 20 minutes to bend and shape the timber before it hardens. With each plank weighing up to half a ton, the installation becomes a task that is as grueling as it is delicate. Once in position, the planks are pressed tightly against the frame using heavy-duty clamps, then secured with spikes up to 350 millimeters long. The head of each spike is wrapped in tar-soaked hemp to ensure a watertight seal, protecting the hull's integrity against seawater. Every detail must be precise to the millimeter, as even the slightest misalignment could compromise the entire structural framework. Gradually, as the layers of planking close in, a seamless and formidable hull is created. This is the moment the vessel truly achieves its physical form, no longer a collection of disjointed parts, but a unified entity, ready for the final steps before setting sail. The construction of the masts requires a vast number of pine trees, each measuring approximately 55 to 60 centimeters in diameter and reaching heights of 16 to 17 meters. All the timber used for the vessel is harvested during the winter months to minimize the moisture content within the trunks. After being transported to the Terra Nova shipyard, the logs must be sawn immediately using a specialized circular track chainsaw. The ship features 3 masts, with the largest mast being assembled from multiple trunks to achieve the necessary diameter. Instead of using a single solid block of wood, the masts are constructed from several sections assembled around a central core. These timber components are machined with precise interlocking grooves, allowing them to fit together perfectly without the need for adhesive, resulting in a structure that is both exceptionally strong and flexible. Once assembled, the entire mast undergoes a lengthy seasoning process to stabilize its structure. The surface is then treated with anti-cracking oil and a protective red paint to mitigate the effects of weathering. A prime example is the bowsprit, which is composed of 7 separate sections spanning over 16 meters, a testament to the sheer complexity and scale of this engineering phase. This is the nearly completed bowsprit. The ship features 3 lower masts along with the bowsprit. Above them sit the top masts and yards, which combine to form the rigging system. The scale of this stage is immense, with hundreds of tree trunks utilized. While the masts, bowsprit, and top masts are crafted from pine, the yards and smaller spars are made from spruce. Remarkably, the 2 main masts alone consumed 40 large pine trees, each measuring 60 centimeters in diameter and 20 meters in length. Once the masts are finalized, the installation process begins with the attachment of pulleys, suspension lines, and auxiliary fittings. Critical metal components are heated to approximately 700 degrees Celsius and then swiftly fitted onto the wood before they cool, allowing them to shrink and tighten the structure naturally. To protect the timber from the effects of heat and the environment, these areas are coated with grease and special protective layers. As the masts reach completion, the sails begin to take shape. The entire set of sails is crafted from linen, covering a total surface area of approximately 1,950 square meters and is stitched entirely by hand. A single large sail can span up to 250 square meters and requires more than 87,000 individual stitches. Every seam must be strong enough to withstand the immense force of the wind, yet flexible enough to distribute that pressure evenly. Once finished, the sails are more than just components. They are the engine that converts wind power into motion, allowing the ship to truly come alive and begin its journey. In the final stage, the entire hull is tightened into a unified structure. Long bolts passing through the hull are clinched from the inside, combined with approximately 200 forged steel brackets that enhance the rigidity and stability of the framework. Simultaneously, naturally curved oak supports are also utilized, leveraging the inherent shape of the wood to provide superior load-bearing capacity at critical joints. A unique aspect of this stage is the use of oak roots to create structural joints. Unlike standard straight timber, roots possess inherent natural curves that are perfectly suited for joining sections like the ship's sides and the stern. The shipwrights select robust root sections, which are then cut and carved to meet the required dimensions. These joints do not merely increase durability, they also reduce stress at connection points, creating a structure that is both formidable and yielding, staying true to the spirit of traditional shipbuilding techniques. Once the framework is fully reinforced, the deck levels are installed. First, critical locations, such as the bowsprit bedding, are precisely drilled to ensure a perfect fit. Subsequently, each deck plank is laid across the transverse beams and securely fixed with spikes. High-stress areas, particularly around the mast steps, are further reinforced with additional clamps and auxiliary structural supports. With the main structure complete, the vessel enters the sealing phase to withstand seawater. 3 deck levels are assembled from more than 700 pine timbers, precisely fitted into the structural framework. Next comes caulking. The craftsman uses wooden and iron tools to drive hemp fibers and tarred strands into every seam between the planks. This process is carried out not only on the decks, but across the entire hull, ensuring that every joint is tightly sealed. Once finished, a layer of boiling tar is applied over the surface, forming a protective coating that repels water and enhances durability in the marine environment. Parallel to the completion of the hull, the steering system is also under construction. The rudder is fabricated from multiple joined oak timbers, weighing approximately 4 tons, a massive scale necessary to maintain control over the entire vessel while underway. Once finalized, the rudder is mounted onto the stern post and connected to the large steering assembly. Despite its 18th century appearance, the ship is integrated with modern systems to ensure safe operation. First, engineers drill a passage for the propeller shaft through the hull, a process requiring high precision to avoid compromising the structural integrity. Inside the former cargo hold, 2 16-liter diesel engines are installed to provide propulsion when there is no wind. These are supported by a storage system consisting of 36,000 liters of fuel and 20,000 liters of fresh water, distributed across 8 stainless steel tanks, enabling the vessel to operate for extended periods at sea. Notably, all of these systems are discreetly arranged within the hull so as not to detract from its classic exterior silhouette. This represents a balance between 2 worlds, a ship carrying the soul of the past, supported by the technology of the present, allowing it to exist and function in both. To ensure high-precision reconstruction, engineers utilize CAD systems to simulate the entire hull and develop detailed technical drawings. This technology allows for the control of every curve and proportion, elements that previously relied solely on the experience of master shipwrights. Inside the hull, a suite of modern systems is installed to ensure safety and operational stability. From watertight bulkheads, sprinkler systems, and sewage treatment to electrical, firefighting, and power supply systems, all are neatly arranged, hidden within the timber structure. The greatest challenge lies in integrating over 40 modern systems into an 18th century design. Every detail must be installed so that it remains invisible from the outside and does not interfere with the ship's operational capabilities. This combination is most evident in the deck structure. The two lower decks are designed to modern standards, while the two upper decks are reconstructed almost exactly as they were on the original ship. It is now June 2003. After 10 years of arduous labor, the time has finally come to launch the ship. The K-bracing is removed and the stabilizing sandbags are cleared away one by one, allowing the full weight to settle onto the launching cradle. Once everything is ready, the vessel begins to move. Centimeter by centimeter, it slides off its supports and advances toward the Göta River. This is more than just a physical movement. It is the moment a land-bound construction officially becomes a creature of the ocean. After the launch, the masts, each weighing approximately 9 tons, are stepped using a crane. This process demands extreme precision, as the mast must pass through multiple deck levels while maintaining absolute vertical alignment. Guiding tools help align every detail, ensuring the rigging system remains stable for future operations. Following tradition, a coin is placed beneath the foot of the mast before it is secured, a blessing for a safe journey. Once complete, the vessel is truly ready to catch the wind and set sail. Once the assembly is complete, the ship is further protected with wood tar, a coating that provides waterproofing and mitigates the damaging effects of sunlight. The rigging, particularly at the bow, is reinforced to prevent it from being lifted by powerful wind forces. The mast shrouds are adjusted to eliminate slack, ensuring stable tension. This is a critical factor in allowing the entire sailing system to function with precision once the vessel is underway. Inside the ship, living quarters such as cabins and sleeping berths are gradually finalized. Simultaneously, the installation of mechanical systems, piping, and technical equipment continues, ensuring the ship meets modern maritime safety standards. By the spring of 2004, the 3 main masts are finished. The vessel is covered with tarpaulins to continue the final stages of preparation for its maiden voyage. The ship departs from Gothenburg, carrying with it the expectations and the legacy of over 10 years of labor. Its maiden voyage takes it past the northern coast of England and on to Cadiz, a familiar trading hub throughout history. From there, the vessel enters the Atlantic, running with the prevailing winds toward Recife, marking its first major milestone across the ocean. Leaving Recife, the vessel traverses the South Atlantic to reach Cape Town, where the crew is rotated. From there, the ship strikes eastward along the 38th parallel, harnessing the consistent roaring 40s winds to reach Fremantle before turning northward toward Jakarta. In Jakarta, the vessel restocks with fresh provisions before embarking on its final leg. The journey across the South China Sea brings it to Guangzhou, the historic destination the original ship had once set its sights upon. This is more than just a voyage. It is the repetition of history itself. A ship that once lay submerged on the ocean floor has now retraced its own path, serving as a testament that the past, when preserved with enough dedication, always finds a way to return. Reflecting on the entire journey, this ship was created not just through engineering, but through time, memory, and human perseverance. From timber that took hundreds of years to grow, to iron bars forged in fire, from every rope to every sail, all were connected not merely to form a structure, but to reconstruct a piece of history. There was a rhythm throughout that entire process, a rhythm of slowness and precision. No step could be rushed, no detail was unimportant. Every stage, no matter how small, carried the responsibility of the entire vessel. And it was precisely that meticulousness that transformed lifeless materials into a living entity capable of moving, facing the storms, and surviving the vast ocean. Notably, this was not a mechanical reproduction. It was a balance between two worlds. On one side, traditional craftsmanship, where everything was done through experience and intuition. On the other, modern technology, discreetly integrated to ensure safety and operational capability. This combination created a ship that is both faithful to the past and suited for the present. When the ship was launched, when the masts rose and the sails caught the wind, More than a decade of effort converged into a single moment. That was when the ship left the dock, no longer a construction project, but an ongoing journey. And then, as it retraced the old route from Europe to Asia, across oceans and harbors once marked by history, the ship moved not only through space, but through time. It bridged the past with the present, turning a closed story into a continuing voyage. Ultimately, what remains is more than just the image of a ship at sea. It is the meaning behind it, that humanity possesses the ability not only to create new things, but to preserve and rebirth old values. That history is not something that sits still in books, but something that can be brought back to life, if we cherish it enough and are determined enough to do so. Because, above all else, this ship was not just built to sail, it was created to remind us that some things, though they have sunk into the past, can always be brought back to the light and continue their journey. Thank you for listening to the end of the story. If you enjoy videos like this, please like, share, and subscribe to the channel so you don't miss our upcoming stories. RaWMachines says goodbye, and we'll see you again.